Okay, so you understood the idea. You understood the idea. I think we recorded this. When we started the class, we recorded, right? Yes, right? So this is the heat map, right? So it takes time. So parallel computing is essential, right? Parallel computing is essential. Now the idea is we will do parallel computing. That is one of the answer we got. But there are even two types. There are even two types of parallel computing we have, right? What are the two types of parallel computing we have? One is in system. I mean, it is placed in your university. Okay, here we have DGX cluster. Okay, NVIDIA DGX cluster, which is high powerful GPU computing. It has 10,000 GPU cores. If you know about GPU computing, then you can like very easily do this parallel processing and get over that. Okay. However, if you are aware of CPU computing, then there are around 300 or 400 CPU cores. So 300, 400 CPU cores you can parallelize at the same time. Okay, it's like using the 300, 400 computer systems parallelly at the same time. Okay, that's the idea. Fine. So it is, there are two options. One is it will be placed here, like it is placed here in our system, in our university here. Other is it will be online. Like you don't have to, suppose you are not a student, you are working as a professional, and you don't have your institute or infrastructure doesn't have a parallel computing architecture. Okay, but still you can get it. How? You can use Amazon. Okay, Amazon services, AWS, Amazon Web Services. Okay, in that Amazon Web Services you can get a computer for free, a virtual computer, where you can select how many cores you want, how much RAM you want, okay, how much memory you want. All these things you can fix and you will be billed accordingly, right? If you want, say, 2 TB of data, because you might be generating high quality plots, right? Heavy, high resolution plots, right? Each plot may be 100 MB, each plot, because they are so color coded, each color code has memory, right? So each figure, if you believe me, my figures, my heavy, high quality figures usually go up to 150 MB, okay, each figure. Okay, so very difficult to even rotate and see the visualization because it's such high resolution figure, right? My computer system halts, okay, because it doesn't have that much of graphic card and processors. So you can use AWS system for that. Now why we are talking about this? We are talking about this because you have to store data finally, right? We have to store data finally. So similar case, there are two different types of data warehouse also. Okay, one will be in system placed, another will be online based. Okay, there are two different types of data warehouse: online based data warehouse, in system placed data warehouse. I mean, it will be available in physical form in your system, like in your institute or company or university. But there can be an online data warehouse as well. Okay, so there are two types of warehouse, data warehouse. Okay, can be online, can be physical models. So this is just I wanted to tell you before we go into deep. Okay, now you almost have much of the ideas so far. Okay, fine. So this is what data warehouse does. So it's a computer system designed to store and analyze a large amount of data for your organization or companies, right? So what it does, as usual, like it gathers data from different areas of an organization. Okay, from different organization, it will gather data and store it in a single data warehouse. Okay, so when you have different organization, like this is organization, this is an organization, and this is the main one. So all of them will communicate to this guy. So here again, the word of schema comes. Okay, schema. What kind of schema we are using? This is a star schema. Okay, if you have more of the subsets like this, okay, more of the subsets like this, so it will be more of a snowflake kind of a structure. So that it will be called as a snowflake schema. Okay, star schema and a snowflake schema to store data. So you can see gathers data from different areas of an organization. This single words tells us about schema. Okay, this words tells us about a schema which will come later to us. Okay, and one of the important topics of this course also. So it integrates and stores the data as usual and then makes it available for analysis. Okay, you can see this is the data warehouse. where it has been storing lot of different data sets here, and then it gives for further analytical processing. That is, whether you want to do any visualization, okay, whether you want to do any kind of data analysis on that data sets, right? Fine. Okay. So you can see it can some mostly it is useful for business intelligence works. Okay, business BI, business intelligence activity. Yeah, and mostly used for to get insights from your data. Second point I won't come to much because it more relates to the business perspective. Okay, decision making. Okay, suppose you can say, suppose there is a famous mall here in a state. Say it is, this is the name of the mall. Okay, so this is the name of the mall, and in this mall what happens is you have in different cities you have this mall. Okay, say in city A, this is city A, and this is city B, this is city C, city D, right? Now there is a main mall which operates each of these sub malls, right? I mean there is a main uh, mall which can operate all these malls, right? So what they will do, each of these malls will give their overall sales of the month. Okay, overall sales of the month, which one sold more in this month, which clothing or accessories have been selling much, has dates been selling much this time of the month. Okay, during Onam, which one sold more. Okay, so they are giving your data analysis perspectives to the main mall, okay, to the main mall, and the main mall takes the decision, right? Takes the decision. The main mall takes the decision. So this is why decision making is used here. Okay. So more of a business perspective, this idea we are using here. Now, fine. Let us see this one. So you can see. Sorry. Okay. So these tiny things written in red, I found that it would be better if I could show it now. Okay, so this is the new thing I have added. So I did not had any place, so I added there. Okay, so what the data warehouse system supports? Okay, data warehouse supports a variety of advanced analytical features. Okay, that help organizations extract meaningful insights from their data. Okay, so this is how it differs from a just a data storage system. Okay, how data warehouse is just different from a what you call a hard drive. Okay, hard drive, right? So because it can do advanced analytical processes with it. Okay, that's how data warehouse is different from any storage systems, right? So you can see it can support data mining, it can support AI tools, it can support ML tools, it can support your front end reporting. Once the data comes, it might report that yeah, data is missing some values. Okay, it can also support this OLAP. Okay, OLAP. So there are some names you will be seeing in this module: OLAP and OLTP. Okay, so OLAP is something known as online analytical processing, whereas OLTP is online transaction processing. Okay, so these are some of the most important terminology you will see. Okay, another important terminology you will see in this module is ETL, ELT. Okay, these are like extract, transform, learn. Okay, and ELT. This will come in the next slide. Don't worry about it. Okay. So just these will be the catchy phrases in this module, like schema, which schema like star and snowflake. Okay, these will be the center of attention in this module. Okay, these three: OLTP, OLAP, ETL, ELT. Okay, schema, which schema, star schema or snowflake schema, right? So you can see this we already discussed. Data warehouse systems stores data, but they support some further processing, analytical processing. That is, they support data mining, they support AI tools, they support ML tools, and OLAP. Okay, so this is how data warehouse system stands out. Okay, this is why data warehouse deserved a separate name to it. Okay, rather than just a data storage system. Fine. So okay. OLAP is referred to as online analytical processing, which provides the last point you see, which provides fast, flexible, and multidimensional data analysis. Okay, for business intelligence and decision support applications. You can easily see the word of business intelligence and decision support. What is the relation between the two? I already gave the example of different malls. Okay, so OLAP supports fast, flexible, multidimensional data analysis. That's what you have to know. Okay, what's the use of OLAP? Online analytical processing. It can support the analysis of multidimensional data. Okay. So last point, as usual, data warehouse are not just data storage systems. They form the foundation of modern analytics. They support data mining, AI ML applications, and real-time business intelligence. So they have something more than just data storage. That's what is the catch here. Okay, that's the take-home message. Okay, data warehouse therefore stands out from just a data storage system. Okay. Then another interesting topic is something known as ETL, but I think that will be better understood if I show this animation or picture which I got from LinkedIn, okay, from Pooja Jain. Okay, so you can see what is the difference between these different specifics. What is ETL? Okay, extract. ETL stands for extract, transform, load. ETL. Okay. Extract, transform, load. Okay. So it's basically a data integration process. So most importantly, it's basically a data integration process. Data integration. Okay. So it combines the data from multiple data sources into a single and consistent data store. Mind you that it combines all the data into a single data, fine, but in consistent way. That's more important. So the word consistent holds more important. Okay. That is loaded into a data warehouse or other target systems. Okay. More about ETL you can explore from this IBM website. More about ETL you can explore this IBM website. I suggest open this IBM website and try to understand what extra they are telling you. So you can see this is the ETL. The first one is ETL. Take the orange, okay. Transform the orange here into the grinder, okay. After that juice is there, so you load it into the truck and deliver it. Okay, extract, transform, and load ETL. Whereas ELT is you extract the oranges, load the oranges. After loading, then you process it for juice, right? ELT. Okay. What is ETLT? ETLT. ET means extract. Okay. First extract those oranges, then transform those oranges. Okay. For T, ET, then L, that is load those juice, okay, and again transform it. Those juice you can further transform into ice creams, okay. So that's the idea. There can be many such terminology here, but she put the most usable ones, like most regularly or frequently used ones. Okay. But this is the fact that the modern data engineering playbook, we should stop asking when to use ETL or ELT. Rather, we should start asking what data recipes power my AI tools or AI systems. Okay, that kind of I mean, these relation to AI might not be getting now, but I suggest that whenever you learn ML and all in next semesters or further semesters, these might again revisit you. Okay, ETL might revisit you when I think you will be learning about predictive analytics next semester or NLP in the next semester, something like that. So, if you are having any traditional ML tools, then ETL works usually because serve fresh the juice. Okay, if you are exploratory AI, then store the whole fruits and blend it later. That is ELT methods. If you have this any further scaling of AI tools you want to do, large scale AI tools, then you can use this ETLT: extract, transform, load, and again transform. Right? Anyway, so This is the word I wanted to tell. Like AI is of course the promised land for enterprises and automatic things, right? For intelligence and for large scalability. Of course, you know now, in many of the um, what I can tell, like companies which are growing or startups, in the background they usually use GPT. Okay, they usually use the free full version of GPT, which is in the back end. Okay, and in the front end they are packaging things and they are getting the users work done. Okay, so even with using GPT, they are getting the companies and startups made. Okay, and they are flourishing now. Okay, so therefore it is scalability. It is up to your interest and your imagination. Okay, how much you want to scale it. Fine, but without the right data pipeline, it is chaos. Okay, so this data warehouse is that data pipeline. Okay, is that pipeline is right data pipeline where you can store data, which can process data, which can have many of these analytical processing in hand. Okay, okay, so this is the story so far of data warehouse. Maybe next class we can see more on it. Okay, so with that, maybe we can stop for this class.